Hello and welcome to another video. Today we have an MSI MPG X570 Gaming Plus from review on our bench. Hi Daniel, the board is an MSI MPG X570 motherboard. Bought it from Amazon about 5 years ago and it was working very well until I decided to change the RAM. Probably then it stopped working, changed the RAM back, nothing happened, changed PSU twice, still nothing. I think much of blown something, don't know what it is. Hope you can help me. Good luck. Okay, this is from a viewer called Clayton, not too sure. But we will have to figure out what is wrong with this board. Because the board doesn't post anymore after he has tried to change something, I would expect that there might be something knocked off on this board. Could be a BIOS issue, but unlikely. Most common reason is for physical damage somewhere when people try to take the board out for something or try to change the case or change a cooler, and with all of that there can always be physical damage that can happen on boards. I wouldn't think that there's anything shorted, because that would have to happen just by coincidence then. So let's have a good look now. Can see a lot of thermal paste, and I can already see a knocked off component. Yeah, and I'm pretty sure I know what it is. There I can see a knocked off component right there close to the CPU socket. And as far as I know, that is for sleep state 4, I think. Yeah, that's like, if I know this correctly, this is a double AND gate, or this is just a single, that is just an AND gate that is taking signals from S3 and S4, or creating S3 and S4. And yeah, so that didn't take long, because that's a 5-pin component and all of the pads of it are ripped off as well. That's why I could instantly tell that there was something missing. Like, I have not had a look into this onto this board before. He left his speaker here. I just thought, is that my speaker? But that isn't my speaker. My speaker is here. Interesting. Okay. Yeah, he left his beep speaker onto here. Okay, I probably have donor boards where that component is on, but the big question is, how much work will it be to transfer those tracks, or like get them working again? I can also see that the SPI header took a hit close to the BIOS. So let's have a good look then. We need the microscope. Let's switch over to that view. So first of all, let's bend these ones back before I forget to do that. Like, this port usually isn't used if you're not programming BIOS through these, so it doesn't matter. The most important thing is that they are not touching and that there's no broken off components close to here, but I don't think so. So this area also looks good, and now we get to the area where the damage has occurred. So yeah, you can see some tracks right there that got a little bit of a nick, but they should be fine. And yeah, there it is. This is the area that actually got damaged. Let's see. Important for us here is this component that was here. Let's see, where are these tracks connected to? So you can see this one goes to that leg and goes up to that resistor. Then you have this pad right here going to that resistor and to here. Then we have, no, this is fine. This is just dirt. We have this leg that is only connected to that solder point right there. And then we have this leg going here and this one going to there and to the top of the resistor. Okay, so this one is easy. This one we can just throw from here to the leg and from here to there. Then this one is also easy. This we can just take this solder point. This one is easy. We take this solder point to there and then also connect it to there. And this solder point is only going to there. So this is the difficult one, and this one. For these two, we have to rebuild the tracks, or at least some part of wire to rebuild, in order to put them under here so we can solder that on. It would be good to confirm that with the board view, but I'm pretty sure that I've gotten the layout right. Let's clean up the area a little bit with IPA. That often makes it a lot easier to see what has happened here. So would be very interested if there's any more damage, but now you can see after the clean, you can very easily see this one goes up there and this one only goes there. And yeah, we will have to see if there was a component ever here or not. It might have been, it might not have been. Let's look around the PCIe slot a little, around the CPU socket a little bit more. But all of this looks fine, close to the PWM controller right here. Also everything fine. Top left of the board, also looking good. Let's have a look around where the PCIe latches are, because this one is also broken. We can definitely transfer. Oh no, we cannot transfer. This PCIe slot is actually broken to a point where it needs to be replaced, because the guide where the lock would actually write on is damaged. Because you can see this right here, this is the guide where they would run in, and it is damaged here, so it won't hold properly. And we definitely have to take a look at this here, because this resistor also looks bad. Have to take a good look there. Because we have heavy physical damage, I just want to check around the board that if there maybe is more that could have happened here. But so far so good. Let's look around the battery then. This looks fine. Nothing here. This is, I think, 3VSB area right here. And then this is power good signaling that is coming in there. And then let's have a look. This is Ethernet. No idea what that is. Ethernet. This is, I think, audio. Yeah, there's also scratches here, but nothing looks to be damaged. Let's have a good look. Yeah, this is the audio controller. And let's now have a look. This is our SIO. And SIO area looks to be fine as well. And another SIO or an RGB controller probably used in this case. Also looks fine. Let's have a look where the power button mounts. That area also looks fine. And above the PCH heatsink also looks to be in good condition. Okay, so what we will have to do is this resistor right here. Let's check that instantly, what this is, if we can still get a proper reading out of it. So let's go to this capacitor right here and this side of the resistor. 10 kilo ohms. Yup. Around 10 kilo ohms. Okay. I want to touch this up because I do not trust that. That is a little bit like, I don't know if that's dirty or rusted or whatever, but I want to touch this up so I don't have any headache with that. So after having applied solder, let's just quickly get the hot air station and hot air this in. Just get a quick reflow onto that component. Just like that. Component is reflowed is in its place. So that won't be a problem anymore. And quick check after having soldered that resistor on this side. Yeah, 10 kilo ohms. Okay, good. Then let's proceed to the actual area that is damaged. We will need my Dremel tool. So what the plan will be, just to restore 2 of the traces, and for the rest we are just going to run jumper wires. So we're going to restore this one and this one. we're going to be jumping then from there and from here. And this one, we're just going to use a jumper from this. We're going to use a jumper to there also. And from this, we're going to jumper there and there. So let's first use the grinding pen and grind a little bit of the masking away so that we can actually solder onto here. So kind of like that. Let's get a sponge to clean that up. I can really recommend these nano sponges. Like, first I thought that they're not really worth anything, but they are pretty good. Because they're so cheap, they're so disposable, just take another one when one is dirty and just move on. It's great. So, and now let's put some solder onto there. Onto this pad right here. Just like that. Where we can attach a wire. We can also, let's solder up all the points that we will need. So we're going to solder this up. We need solder on these points right here. And we will need solder right there. So let's see right here. Let's get solder on both of these pads right here. And then let's put solder on top of the resistor. Then these two pads. That was a capacitor. Then these resistors right here. On top of there. And then we have, I think we have everything. This has solder here. And we have these two. This goes there. This one goes to this one, right? This one goes there. This one goes there. And that goes there and to the top. Yeah, we should have everything. Then let's get a piece of wire. So let's see right here. This is 0.15 of a millimeter of wire that we will be using right here to rebuild this lowest track. So let's tin this up right here. Now it's tinned. Now we have a proper connection. And let's cut that off without cutting anything else off of here. So let's do about right there. Now we have one jumper wire for that. And let's see, the other one for the next track needs to be, it goes up. Yeah, I need to have a look again. Need to clean this up once more just to be sure. I think it's to the bottom of the second resistor where we need to go for the middle one. Yep, it goes to the top of that. It goes to the top of the second resistor. So let's put flux there. And then we're going to be using the wire again. So some flux onto there. Let's get a little bit more solder onto the top of that resistor. So it can actually hold the wire well. Kind of like this. Let's get the wire again. Let's attach the wire to here. So the wire is attached. And because this is enameled wire, so this has a coating that it's not conductive, except if you burn it off, like we done for where it contacts, we can just put this in between here and run it where the original trace was going. And then we're going to make this bend right here. Then let's see. I should be able to just snip this off because this is so long. Kinda like there. That should be fine. And now the wire will go here. Let's take another pair of tweezers to put it where it needs to go. Like that. Now the wire is where it's supposed to be. What we can now do is we can now insulate those places with UV mask. So we just need a very, very thin layer of it. The UV resin that I have is like really low quality. I really need to go get that transparent stuff that is so good that I've seen so much. Because the one that I have is like not really getting sticky, not really getting hard enough anymore. So a little bit of insulation here and a little bit here. And that should be enough. Enough for it to hold in place like we needed to. And getting the UV lamp onto here and the area cured. So we insulated the place. Let's now, we need a board view actually now, because I need to find out what kind of component that is and if I have that anywhere. I'm pretty surely I will have that somewhere, but yeah. Because the rest we can just, oh yeah, one more thing that we can do now is we can pre-tin these wires. So with a little bit of flux, we can pre-tin them in order to have it easier to solder them on later. So we just want to get the enameling off of the top of them. Now you can see both of them are tinned up. Now it will be easy to put a component on top of them and to then solder them on. So let's get a board view. We need a MS7C37. So on our board view right now, we see this is an NC7SZ08, whatever this is. And this takes on APU SLPS3. And yeah, this is for sleep state 3 in order for this board to turn on. Let me quickly see what that component is. But I'm pretty sure that is like a AND gate. Yeah. It is a UHS 2 input AND gate. Yep. So let's have a look if we can find one of those. But before we do that, let's have a look. There was no component fitted here. And there was no component fitted here. You can see that XR2 and here X0R. And this is how it normally looks, 2.2K4. But yeah, this is not fitted and that is not fitted. Let's see. This one that we've redone is actually ground. Actually, we didn't have to do it like we did it here. We actually could have taken it from the capacitor. This one only connects up there. That we got right. Where does it also connect? To the CPU socket. Okay. Then this one, yeah, with this one we saw this one connects to this resistor and to the resistor up there. Then this is 3 VSB. This connects to a lot of places like the capacitor. We will jump from there. And for this one, it connects to the lower side of that resistor that isn't there, but to that part that we saw there. Where does it also go? All over the board, okay. But this is an end stop that we have, so it doesn't continue anywhere further from here, where it also needs to be connected only there. For example, this point here is not an end stop, it's in between that connects this point to this point also, and we have to restore that connection. Okay, let me see if I got this thing on one of my donor boards. And now we are on a B350M mortar. And yeah, the exact component is fitted right here. So I can take it from here and put it onto our board. And as you can see, it's an NC7SZ05, NC7SZ08. Yeah. Okay, let's take that off and put it onto there. We can start to solder the first few points and then get the rest of our jumper cables onto there. So here we are on the donor board. Let's take that component off. We are going to apply leaded solder to all of the legs in order for it to come off more easily. That's all of the leaded solder applied. Let's hot air this off and get it onto our board. There it is off. And let's get our donor, our actual patient in now in order to receive that. In this case, it is oriented the other way around than on the board that we just saw. So we need to put it this way. and put it onto here. And now I want to solder this onto the few supports that we have, those two legs, in order for it to hold properly already. And we can now see where we have prepared the area. Some flux onto there. Let's get the soldering iron. We're going to be pushing down onto this. And we're going to solder to it. Like that. And also like that. Pretty sure that should be fine now. Let's clean that up and check that our soldering is actually fine. That those legs are properly connected and that those signals go where they need to go. So let's see, we're going to go into continuity mode. And we know the bottom right, this one should be ground. It is connected, and this one goes to there. So only on the leg and on the resistor. Let's do it this way around. We have a good connection. And do it once more here, just on the leg. And ground from the capacitor. That is all fine. That is very good. Let's then continue now to put on some jumper wires. So let's continue with the one remaining leg on this side. This one right here with that resistor. So let's take one bit of that wire, of that enameled wire that I use. So we are going to be starting from this point here, connected to there. Then we search our next point, which is that leg of the AND gate. So we're going to apply solder to there to have a good amount where the wire can stick to. And let's get that onto here. Let's take a little bit of a different route, that it doesn't just goes to the front there, but we go like this and then do another bend over here. Right there. Okay, now we have the bends that we need. Feeling like a plumber doing copper plumbing bending. And there's the connection to that. Now we have the first connection made for it. And now we're going to go to that resistor. Let's apply a little bit more solder to the resistor. Really struggling to get the enameling off of this wire right here. There we are. And there it's connected. So let's cut that end of the wire off. Right here. And let's clean it up once more to have a good look at what we've done here. So, here we have it. We have a connection made from that point to that leg and to that resistor. And now we've rebuilt what needed to be. This is connected to that wire right here. This is connected to this one. Now we need to connect a wire from this point across to here. And after that, we just need that capacitor to, that leg to connect to that capacitor up there. So once more, there's still mostly flux around the chip, but let's put flux onto there. And let's take our wire right here. Now it's connected. And now we're going to be putting a bend into here in order to get it to this leg. And now let's put some solder onto there. Really struggling with the enameling today. There it is. Now that is connected as well. Let's cut it off again. Let me get a different angle for this. Come on. There we are. Now this is connected. And let's now get from this capacitor to that lag. So connection to the lag and the capacitor. We're not going to bridge it. I just wanted some more solder onto them. I'm going to put a proper connection to them. And now wires connected to the capacitor. And now let's get it onto the lag. And connect it right there. And so let's get that cut off once more. And I think we have done it. Let's clean this up very well in order to see at what we have done here. Our botched job. So this leg connected to that point connected to the third leg and to that resistor right here. Then that resistor connected to the middle pin, that pin connected under it, this pin connected here as we said, and the capacitor connected to here. And this should be it. There was no component here. There's no component here. This isn't touching, as you can see, right here. This is just closed, but it isn't actually soldered to there because it's insulated. And yeah, this should be it for this repair. Hopefully this will work now. And if it boots up, we will insulate all of this, even though it is insulated wire, but just in case, put like coating on top of it. But let's put a CPU into here and actually get this booted up and see. So I wouldn't think that there's anything shorted on this board. Nothing's blown up. So CPU's in. Let's get a stick of RAM onto here. We do already have a beep speaker from him, which is great. And we're going to also put a power button onto here. Let's get our power supply attached. Put a cooler onto here. And I'm going to be so bold. And I'm going to be putting in the post screen already. Because I think this will be all of the issues that this board actually had. Because this very well would mean that the board won't boot if that isn't fitted. So let's see then for the passive power consumption next. 130 milliamps. That looks very fine. So pretty sure we will have a reaction to the power button. So let's hit it together. We have post LEDs right there, but we're going to look mostly at the current. 2.2 amps, that looks very good. Power button, CPU LED. Let's see now. Does it go further than CPU LED? And currently it doesn't. 2.2 amps and stuck. This might be because of the processor, but I don't think so. Do we have V-Core? Is this getting hot? Yes, it is getting warm. So let's reset the BIOS then, because V-Core is definitely running. It should be loading. It should be going through the BIOS boot up process right now, but it isn't. We will have to see if there's more damage around the BIOS, but let's see for the battery first. 2.8 should be fine, but still, let's reset. So we're going to take the battery out. We're going to take the scalpel, and we're going to be shorting the JBAT connector for clear CMOS. Would help to turn off the power supply while doing that. Okay, let's see that again. If resetting the BIOS has had any effect on this. And it didn't seem to have any change. We do have just a little bit of changing power consumption, but not really. Okay, let's get a different CPU into here just to be sure. Let's get like a 3100. So let's see with the 3100 if this has any difference. 2.7 amps. 3 amps. 2.8. And there it goes. Yep. 4.6 amps resetting by itself. That is very good to see. So it was just the CPU that it didn't want to have. We probably get a complaint every second now about VGA not being connected because this is a 3100. There's a VGA LED to 3.2 amps. Yeah, and the speaker might actually be dead. Let's put my speaker onto here. No, nothing out of the speaker. But I'm pretty, yeah, we're stuck on a VGA LED, which means this board is pretty surely it is turned on. We might be able to see that via the indicator for a keyboard. No, we're not able to see that. Okay, let's then turn this off and get a GPU into here. So GPU is on here. Let's now turn this on once more. And let's get an actual post screen in here. And there's the post screen. That is very great to see. And because I'm suspicious of this BIOS, I will be getting the newest BIOS for this board and will be flashing that onto here. Because you might have tried to use the flashback function for something. And yeah, because it was weird that the 2200G wouldn't want to boot on here. It might not be supported, but still. Let's have a look at what BIOS is on here. Device is changed. Yeah. F1 to run setup. Let's do that. The BIOS is from 2019, so this is an old BIOS. There's the BIOS screen. We are from the, what is that? Probably the 12th of June 2019. This is A10. This is a probably very early BIOS. So let's get a BIOS update quickly onto here. So let's go into M-Flash mode here. I've gotten a stick prepared with the latest stable BIOS. Let's put my speaker off of here and put his one on so I don't forget to change that back. Here we are in our flash mode. Yep, 6-year-old BIOS before. So let's update this to have the latest BIOS on here. Newest BIOS is on here now. Let's see, let's get this thing into Windows then. And I will quickly see for the Ethernet. So M.2 in here. And now also Ethernet. Let's get this into Windows and just confirm that everything's working fine. And the board is fully up in Windows right now. I can see the LEDs flashing on the Ethernet port and it's working, and we have audio as well. So yeah, this repair comes to an end. As you saw, it was a broken piece of an AND gate actually, or like the whole AND gate missing. That is actually responsible for sleep state 3 in this case. And this is a very common piece on AM4 boards and especially MSI. And this happens all the time. Like, I've seen this thing missing more than once. So this is nothing new to me. And when looking at it, it was really obvious. Like, if you've seen how a board looks where traces are ripped off and pads are ripped off, you will instantly recognize it. And there was like 5 pads missing right there. It was so visible. It just jumped at the eye. And the soldering there really wasn't difficult. Because most of them, we didn't have to rebuild tracks or anything. We could just run jumper wires all around. I will be insulating that place a little bit better. So I will be putting some UV mask onto there and will be curing it just to protect it a little bit better. But for that, the repair is done. All of my tools, as always, are linked in the video description. If you want to get one of these current meters, email me and you can acquire how to get them. And yeah. This was Mainboard Medic. Thank you very much and goodbye.